welcome everyone to our webinar today. Here at Transkribus, we will have a look at table models today. So if you know Transkribus, you have probably faced documents like this. You've tried to read those and probably were able to solve them and recognize them with Transkribus. But today we will go one step farther and have a look at how you can extract tabular data from your documents. How will we go through today's webinar? First, a very brief introduction from yours truly. Then we will have a look at the more hands-on things when it comes to working with tables in historical documents. We will look at preparing of training data. We will see how you can train a table model and how you can use a table model. And eventually we will also have time for your questions. And if there are any other questions that can be answered right away, feel free to always just type them in the chat, and we will also try to answer them during the webinar as we go through it. Who's here with me today? First, we have Helene from our marketing and comms team, who is leading the team there, and also Sarah, who's our customer success manager, very experienced with Transkribus. And myself, I'm part of the board of directors and also leading the product development here at Transkribus. But how do we make working with historical documents and especially tables like a breeze? If you know, with Transkribus, it's has become significantly easier than years before to recognize handwritten text, but also tables. If you have a look at this example, and in historical documents, you also have tabular data or pseudo-tabular data that was recorded back in the times. And with Transkribus, you might wonder, am I able to extract that data also in tabular form? Because having this data in a structured form comes with a certain value. And yes, you are able to extract this data in tabular form. Many of you have already tried it out, trained your own table models. And today we will have a look at all the specific details when it comes to training such a models, all the tips and tricks that you might want to hear and see, which my colleagues Sarah and Helene will give you to understand better how you can tune your models, get better results, and eventually have very solid models to extract your data in tabular form. As always, we try to highlight that Transkribus can be understood as your AI-powered ally. So this ally is here and designed to simplify your time-consuming work. If you think of a simple text recognition and then needing to transform that in tabular data, then table models come with a certain time saving, as you do not need to transform your text recognition into a spreadsheet, for instance. It looks like this here. On the right side, you can see it when you have a table recognized. Those table models can actually be trained to automatically detect those rows and columns in tabular form and then let you extract your data in structured form. By the end of today's webinar, you will be able to prepare training data, so understand how training data can be prepared, then actually train your model, but also evaluate how your table model performed, and then apply your table model to the actual corpus that you would like to recognize in your project. But how does that look like in practice? Now I will hand over to my colleague Helene, who will start with a more in-depth explanation on how to work with table models. So take it away, Helene.
Thank you so much. I think my screen is already sharing. Perfect. All right. Then let's get started with an introduction to table models. And as Flo already explained, our trainable table models basically utilize AI to identify the tabular layout and tabular structure of your historical documents. So that makes it easier to not only recognize the text in your document, but also extract the data and export it into spreadsheets. So to really have the correct context and structure of your historical documents. So until now, we focused more on detecting lines and then detecting the text itself. And with table models, again, we're just going a step further, basically. So we're also identifying how is that text organized and structured on the page. So what is the structure of the textual information on the page? And also, how does it relate to each other? So how do table models work? With table models, this now requires a separate model called table models. And with the table model, first the structure is recognized, and then in a separate step, the line and the text. So this adds an extra step, but it also adds value. And once the table structure is recognized, it can also be exported as such. So it can be exported as an Excel or CSV file using our export options. Now, how does that work? When we look at table models, they learn to recognize the rows and columns based on the training data. So when we looked at how to solve the table recognition, our team realized that the most flexible approach is to treat rows and columns separately. And this also has another advantage. It means that tables don't need visible separators. So there don't have to be drawn lines between rows or columns, as long as the layout is visually structured like a table, you can teach the table model to recognize it. This also means that you can extract only rows or columns, of course, also both, but also separately, depending on what you need and what kind of materials you have. I can show an example just in a few seconds. At the moment, we don't really have public models, but you can train them yourself for specific collections or documents for specific tables that you have. The reason that we don't have general models yet is because, well, the tables, they share one general structure or idea, the rows and the columns. There are still a lot of differences and a lot of variations in how many columns there are, how many rows there are, and how many lines appear in each cell, or, for example, also how dense the content and the writing is in the tables. So because of this reason, some models might perform well out of the box. I think we have one public model that is available, but still most of the time it would benefit from training a custom model. So the good news is that training a custom model is quite straightforward, and we'll teach you, of course, today how that works. And if you can identify rows and columns on a page, usually you can train the model to do the same. And with enough training data, you can also train a model to handle multiple types of tables within the same collection. So here we have an example of a table without any visual grid lines. So as I mentioned before, you might have a table that doesn't have visual lines separating the columns and the cells, but still you can teach the model to recognize the lines, the rows and the columns quite well. And this is, for example, what it will look like then in Transkribus. The table models can also handle rotated tables or skewed tables. They don't need to be perfectly straight, but of course you need to train the model with this layout and the skewed lines as well. So the model can learn to recognize the structure, basically. Table cells can also contain multiple lines of text when you train a model. The table model itself doesn't really care about the text content. It really focuses only on recognizing the lines, so the rows and the columns, based on how you train the model. Now, we also have another layout model that can be trained, the field model. And I'd like to shortly go into or clarify what the differences are and when it makes sense to train a field model or a table model. So field models are generally better suited for complex layout that aren't tabular, so aren't in tabular structure. So that can be forms, newspapers, but also marginal notes, marginalia, or any specific regions that you want to extract, because you can also train field models to automatically tag specific areas in your document. So if you only want to extract a few specific regions, for example, a few fields on a page, a field model is more appropriate. You could attempt to use a table model, but field models allow you to label regions more specifically, and you can also train a field model to label regions automatically, which table models cannot do. Field models can do that, table models cannot. So table models are best suited if you have material that has a very clear row and column structure, even again without visible separators. So this includes any type of historical information or historical documents where information is structured in parallel sections or blocks. As you can see here, the examples on the right. So the table models can automatically identify rows and columns, but not tag them. However, it's especially when you work with these types of documents, it's not only important to extract the correct text information, but to also have this text information in the correct order and in the correct structure and relation to each other. So, having clarified the differences and when it makes sense to train a table model, we have now covered the basics, and we can move on to how to prepare the training data for the table model. So as you might know from training a text recognition model, when we train a model, we need to provide the model with data, example data, that the AI can learn from. So how do we get from the table in your document to a structured layout that Transkribus can use for the training or can be trained on? Here it's important to choose the right workflow. Maybe you know this slide already from previous webinars. So compared to other models, like compared to the the text models, for example, we don't have public models available. So in this case, it's important to train your own custom model. This way you control the data that the model learns from. So just to repeat, the custom AI table model training uses specific examples to help the AI accurately recognize and understand the layout in your training data. And before you train this custom model, you need to prepare these examples that the model is learning from. And this is what then the training process looks like for your table models. First, you draw tables accurately in the layout editor, in the Transkribus editor. And then you save these tables or these documents as ground truth in Transkribus. So the number of ground truth pages you need for training can vary a bit. It depends on how complex the tables are that you're working with. So for quite simple tables with not too many rows and columns, 20 pages is enough. For more complex tables, we recommend a starting number of around 50 pages. And for mixed tables or for a bigger variety in tables, we recommend around 50 to 100 pages of ground truth. Once you have those ground truth pages, then you can start your first training. But before we go into starting the first training, I will switch to the web app, and I can show you what that looks like. Do we have any questions so far that we should answer before going into the editor?
There is a question about how the model handles data that is not perfectly aligned with the table, but we will answer it later.
Okay. I see there's another question. If there are multiple tables in one page, we will also come to that later. We will answer both those questions. Okay, then let's start on how you can create the training data. Let me just enlarge the image a bit. So you have opened your document and you can see here on the left side the image of your table. To draw a table on your document, you can click here on the left side on Add Region. And here you can see the option to add table region. Now, you can either manually select the amount of columns and rows that you want. And using this feature kind of depends on what kind of table you have, how regular it is, but just so you know that you have the option to do so. Or you can go back here. Or you can manually draw a table. And you can draw a table by using your mouse and clicking once on the area where you want to start the table. And then you drag the table region to the end and click again. And now you can split this table region into rows and columns. And you can do so by clicking on it and selecting the region. Then you press H on your keyboard and you can see the horizontal line appear. And once you click in the region, you can see now that it has been split into two parts. And you can continue doing so and splitting the table where you want to have different rows. You can do the same with columns, but instead of H for horizontal, you press V for vertical on your keyboard again. And then you can again simply choose where to split your table to create multiple columns. You can also use your arrows on your keyboard if, for example, you have some slanted lines. So let me press H again to show you. And the horizontal lines aren't really straight. You can use your keys, the arrows on your keyboard to move and slant the horizontal line so that it fits the layout of your table better. And if I now click here, you can see that the split and this row has also a more horizontal line. You can also move the line by just dragging it, so picking it up with your mouse and dragging it. So these are a few options on, or this is how you can create a table, and also some options on how to adjust the rows and columns, and depending if they're slanted or if they're even spaced. You can also merge regions, and you can do that by, so let's see, for example, this these two cells we want merged. We can select both by pressing down Control on our keyboard and then pressing M for merge. We can now see that this is one cell instead of the previous two. So if I go to Control Z to reverse, you can see now it's two again. So this way you can adjust and edit the table. You can also add tags to cells or columns to add specific data. So tags are basically indicators that preserve information and context. And you can do so by using your mouse and right-click to assign structure type. And then you can, for example, add the tag name, or depending on what kind of tag you need. Let's see, maybe it should, I think, show up in the layout. Let's have a look if that is because of the label size. Or maybe it's a bug. But it should show, we can see here in the text editor part that the label has been applied. Now, just to remind you, table models cannot learn to apply these tags automatically. the application of tags and adding of tags does remain manual, so you have to do it manually. Now, once you have created a table with the correct layout, save your progress. So click on Save Changes. And you can also save it with the status ground truth. And this is another indicator that this page can be used for training, and that the layout is correct and can be used for training. Now, a few things that are good to know. So with the table models, while they can be applied to a variation of tables, there are some limitations or some things that are good to know when working with tables. We also had the question in the chat, what to do if you have two tables. So let's see this example here, this example page. So when you have two tables, the table model cannot currently recognize them in the same image. So it is better to split two page scans or pages with two tables before uploading to train a table model. Then another thing that is good to know is, while you can merge cells in Transkribus in the editor, the table models don't work with merged cells just yet. Or to explain it better, you can merge cells, but you cannot train a table model with merged cells. So it doesn't really work with irregularities in this grid view. It really works with a very straight structure with even lines and even rows and columns. So with these irregularities, a table model cannot be trained. You can also see this, I think, in this example here, another example here. So here we have merged cells here, and while you can merge them manually, it is important to keep in mind that you cannot train a table model with merged cells. Another thing that is good to know is there is no need to adjust cell borders if you have text that is overlapping. So if you see here, the table model always draws straight lines. So again, similar with the merged cells, the table models really work with this grid view structure. So the model always draws straight lines. You can adjust this then afterwards manually, but it cannot be trained, or this does not help the training data. And you cannot train the model to then have, for example, such a layout as a result. One other thing is regarding headers. So including headers is optional. Let me show you. Loop. There we go. So you don't have to include the headers, especially if the heading is identical on all the pages. If you exclude it in the ground truth, it will probably give you a clearer result. Because again, it does not really fit in the grid for you as it is a separate part. It's not part of the grid view table. So it might give you a better result if you just exclude it. And then once you are finished with the table, you can then still do an extra recognition and include it once you want to export the table with the heading as well. So again, if you have created your ground truth table and you have saved it as ground truth, you can then use this to start the training process. One option to create a larger batch of training data, or maybe diverse training data, if you have different tables, is to create a sample for training. So again, if you have easy tables, 20 pages of ground truth is usually enough as a starting point. But for more difficult tables, or if you have different types of tables in your material, you need more pages of ground truth. And it is important to have all these different variations of tables represented in the training data so that the AI has seen those variations in tables during the training. And one option to get this variation is to create a sample. And to do that, you can select, I'll just select this document here to use as an example, you select your document with your ground truth, and then click on the action button, and then click on Create Sample. So here you can give this a title. Let's just call it Sample Table Model Webinar. And then you can decide how many pages to include in this new document. So these pages, as stated here, will be randomly selected, and this way you will get a variety of the different tables included in your ground truth. So let's say, for example, I want a variety of 50 pages that will be randomly selected, or a variety of 25%, both works. And then I can click on Create Sample. And this sample should now show up as a document here in this collection. You can then use this sample. Let me refresh and see if we have the sample. You can then use this sample that has this randomized variety of ground truth data for model training. There we go. Here we have an example with 49 pages. And now, if the sample isn't large enough, it should include randomly every type of table that has been in your collection. And once you have that, you can start training your model. And I will hand over now to Sarah, who will explain how to do exactly that.
Thank you very much, Helene. Okay, we are now going to see how to actually train the table model. We are in the collection or document overview. So first we are going to select the pages that we have manually labeled where we created our tables manually and that we have saved as ground truth. And then we click here at the top. There is this drop down menu here, and we select table model. As Helene has explained to us, we can only do that after having accurately drew the tables and saved as them as ground truth. And we need at least 20 pages of ground truth to start our first training. The training data, what will be used as training data, is also called ground truth in Transkribus, and are the tables accurately drawn on our images. During our training, when we set up our training, the training data is split into two groups. The actual training data, so the pages on which the model is trained on, and this is usually 90% of our pages. And then a 10% of our pages is assigned to the validation data. Those pages aren't used for training the model, but they are set aside and used for testing its accuracy during training. This is very important because at each iteration during the training, the model has to evaluate itself to know how the training is going and if it needs more iterations. And to do that, it uses those validation pages. You can select the validation data manually or automatically. We recommend to use the automatic selection and to assign 10% of your ground truth to the validation data. And the interface will prompt you to do that. So especially if you are training your first table models, we recommend to stick with those settings. And then we have the model setup page. Here you are asked to enter the name and a description for your model. And here you can also modify the advanced settings. These are the there are 3 advanced settings that you can modify. If it's your first training, it's better to use the basic, the default settings, and those are the correct one in most of the cases. In any case, if you want to have a look at them and modify them, the settings that you can modify are the training cycles, which are the number of times that the models goes through the entire training data set. I think by default it is set to 5,000 training cycles. You can increase it up to 15,000, but it makes sense to increase it only if you have a lot of grant root pages. Like if you have, I would say, more than 500 pages of grant root, in that case, increasing the training cycles make sense and could give you better results. Otherwise, the model will just take longer to be trained, and you can also risk that the model overfits, which means it doesn't learn it learns too much the training data, but then it isn't able to generalize its knowledge when you apply it on new pages. Then there is the learning rate, which affects how quickly the model adapts to the data. And you can modify it, but we recommend to use the default setting. And then you can choose the model architecture. We have 2 options, standard and enhanced. Standard is fine for simple tables, like the one that Helene showed us before. Enhanced, you can select this option if you want to train a model on mixed table types. So the task for the model is more complex, or if you have complex tables, which means tables with many columns and many rows, especially thin rows. In this case, you can select the enhanced option. Just remember that using the enhanced options means that the training will take longer, but also the recognition afterwards will take longer. And then, as I said, also in the model setup page, you are asked to enter the name, the description, and other information about your model, and then you can click Start. The training is launched at that point, and you can always monitor the progress of your training by going to the activity page. And at the point you can close Transkribus and go back to the platform, do something else in Transkribus, or go back to the platform when the training is finished, and you will receive an email when the training is finished. When the training is done, how do you evaluate the accuracy and the performance of your model? There are 2 ways. The first is to look at the mean average precision, which is the correspondent of the Carter error rate for tables models. The mean average precision is a complex measure that evaluates how accurately the system detects rows and columns, considering whether they were detected and how well their size and shape match the validation data. You see this value in the model card in the models gallery. And just remember, keep in mind that tables models with a mean average precision over 35% can already deliver very satisfactory results. So it isn't like with text recognition models where the accuracy should be higher than 90%, so the character error rate lower than 10% to get good results based on our experience with tables model for the last more than 2 years, I think. Even if the accuracy is 35%, and it seems low, but it gives very good results just because the mean average precision is a complex measure, so it includes a lot of variance, and it's very difficult to get a high number here. And the second thing that you should also do is to run a recognition test with your model and visually evaluate the results yourself. Because as I said, the mean average precision could be 30%, but still you get the table recognized correctly. What to do if you have a quite okay model, but you would like to improve it? Because maybe it isn't capable to deal with a certain type of pages, tables, or you see that there is room for improvement. After you have trained your first model and you want to, you can use this model to recognize some additional ground truth pages, for example, 20 additional ground truth pages, then you correct them, and the correction should be faster than drawing the tables from scratch. You save them as a ground truth, and you start a new training, including the old ground truth, the ground truth of the first version, and this newly created ground truth. And this way you can improve your model multiple times, creating new versions of your model. It's important to remember that tables models cannot be trained to automatically tag the columns or the cells. I think Elena showed you how to tag a column, a cell. This can be done manually. But the model cannot learn to do that. So if you want to do that, it can enrich your data and also the page XML if it's valuable for your project, but the model cannot do that automatically. During the training, it's better to exclude the pages without tables. So if in your ground truth document you have also blank pages or pages without tables, it's better not to select them for the training. And writing that ignores separators is tricky for tables models because it disrupts the clear row and column structure they need to accurately recognize and extract data. So there was also a question in the chat about data. In this case, what you can do, you can train a table model to recognize the grid structure, and then you can, before running the text recognition, you can manually modify the cells to include the text that overlaps the cell. Now let's look into the platform. We are here, and in this document here we have 20 pages of ground truth. Let's see the steps to train our first table model. We select all the pages. We go to train model, table model. So they are assigned to the training data. And then I click next, and automatically it tells me that 10% of my training data will be used as validation set. So I can choose the percentage, 10%, 5%, or 2%, or select the pages manually. I'm fine with the automatic 10% selection. Let's go next, and here I have to enter the name, a description, an image URL for the thumbnail if I want, and here below I have the advanced options. For now, let's stick with the standard 50 layers option. and we click next. I have a recap of my training, and if I go here, I click start, and now the training was launched, and I just have to wait. Here I can see my position in the queue, and I can also see it under processes and activities. And if in a few minutes or when the other job training from another user is finished, my table model training will start. To see the result, the model, when the training is finished, you go here, models, my models, and you select the model type tables, and the model will appear here. So you will see your model, all the information about it, the training pages, the validation pages, and the mean average precision. In this case, it was the exact same ground truth that I showed you before. The mean average precision reached is 38, almost 39%, which is very good. We also have to consider that these are quite simple pages. If I want to use this table model on my pages, so let's go to our collection, and let's take a new page. Of course, I need to apply it on similar pages, so pages with the same table structure. I'm here, and as Helena explained, the table model, the table recognition will just give you the table structure, and then the second step after that is the baseline recognition to find the lines, and then the text recognition to transcribe the text. So the table model doesn't do all these 3 steps in one go. We need to run 3 recognition on each page. So we are here, we click Start Automatic Transcription. We select the process type tables, because this is the first step. And also we select here our model. As you will see here, we don't have as many models, just a few, but I want to select this one. And then we start the table recognition. So now we are 4th in the queue. So I don't know how long it might take, probably a few minutes, but we are prepared. So we have always a backup plan. So this is the table structure. Yes. So let me restore this option. So now we have our table. So please ignore the lines, because this is the second step that we are going to do it now. We have the table, and we want to recognize the lines inside the cells. So the second step is to run the layout recognition with one of our public models. Most of the time they are good enough for all the documents. The most used one and the most flexible one is mixed line orientation, but we also have universal lines and horizontal line orientation, but let's take this one. And please remember to always select, if you work with tables, always select those advanced settings. So generation of text regions, you need to select the option keep existing, because you don't want to create new regions, you want to keep the table that you have already recognized. And then with tables, it's usually helpful to reduce the minimal baseline length to low, because it's very common to have very short baselines, like numbers with 1 or 2 digits. And if we decrease the minimal baseline length, we are sure that all those numbers are recognized. And also select this option, split lines on region border, to prevent lines that belong to different cells to be merged together. And you can also increase the line overlap fraction if you want. And now we start the baseline recognition to find the lines, and the last step is going to be the text recognition. Of course, you don't need to do it. Something went wrong, probably because I launched 2 jobs, a job before the other one was finished, but this is the correct version. So we have the cells and the lines, and the last step is the text recognition. We can use the text Titan 1ter, and we can start it, and the results will look like this. So now we have, we can also decrease the text. We have the table, the lines, and inside each cell, the text. To export our results as a spreadsheet, we can go there, select the page or all the pages, and go to export and select as export format the spreadsheet Excel CSV format. This export format is only included in the paid plans, so Scholar, Team, and Orga plans. And here you can decide if you want to merge, if you want to have one table, one page, and so one table per sheet in your spreadsheet, or if you want to merge all the pages and all the tables in one big table in the spreadsheet. And then you click export. The export is started, and you will get an email and also a notification here in Transkribus when you can download the results. This is a way, is the main way in which you can export your tabular data. Of course, you can also export them as a page XML or as a PDF or a Word file. But with the spreadsheet, you can keep the tabular structure, which is the main goal if you work with tables models. Another option is to publish your transcriptions and results with Transkribus site. And here we wanted to show you how a table looks like in Transkribus site, which is our publishing platform. This is the Transkribus site from a archive in the Netherlands. It's public, so you can also have a look at it. And unfortunately, it's only in Dutch. But if we go there, these are police reports. The result will look like this. So it's very similar to the Transkribus editor. You have the table structure, and so it's also easier to read and to search through it in a way like this. Okay, I leave now the floor to Flo for the final remarks.
Yeah, thanks a lot, Sarah. Maybe if you take over the screen sharing. All right. So, as we've heard, quite a lot of things to know, a lot of edge cases and different approaches when you work with tables. Now, as we come to some final thoughts, I will just give a very brief overview about our cooperative in general, and then we have time for some more questions. So if you have any questions in the meantime, just type them in the chat, and then we can have a look at them in case we can take over, or Sarah can take over screen sharing again and show some examples if we have some that can illustrate basically what we are talking about better. But in general, what we hope that we were able to show you, as outlined at the beginning, is that you know now how to prepare your training data for a table model, how to actually launch the training of a table model, and what settings to adapt or keep in mind when you train a table model, and also how to evaluate the table model. And finally, also how you apply your table model, as Sarah has just shown very nicely. What we at Transkribus tried to help you with is to reduce the time-consuming work. So working with the tabular structure is not fun, and actually not what you want to actually work with, because what you're interested in is the content of the pages you're faced with. We try to help you to improve access to historical sources with the help of AI, and also do accurate text recognition, which is our main domain, so to speak, as Transkribus, but not only, as you see with table models. Who is actually Transkribus? Just very briefly, many of you will know it. We are a European cooperative society, so we are a cooperative funded now already almost 7 years ago. Our owners are more than 250 public and private institutions. So we are co-owned basically by many universities and private individuals, also some businesses, but in the end, based on our statutes, we are a for-profit cooperative, but all our profits are reinvested in the platform. So what we do is basically work on Transkribus, work on a mission of Transkribus. So our core idea is to further develop Transkribus, and there are no profits distributed. Basically, if we ever earn profits, they are going directly back to Transkribus, so we can reinvest it basically in our infrastructure and in our software. We're about 25 to 30 team members distributed all across Europe, and some are even overseas in Canada and Argentina. So we are quite spread out. As you see, there's many members that are co-owners of our cooperative. Our goal, as I just want to highlight again, is really to provide the tools for making history accessible, and you, as the users, do the actual fun part and the work with the documents, the historical records and sources. Yeah, you know where you can access Transkribus, so it's on app.transkribus.org. So we provide a web platform, which is our main development trajectory for our platform. And we also have a quite extensive help center. I've seen some help links already being shared in the chat. So always also try to consult our help center. There we have tried to put together comprehensive guides and descriptions about how things work in Transkribus. And if they do not work, we have it later on. You can also check it out on our YouTube channel, but also access our help center and join the conversation we have on our social channels. Quick heads up, maybe next week we will have another webinar with a very similar technology. It's basically the sister technology, so to speak, of table models, which is field models. We will have another dedicated webinar to those models that are also really handy when it comes to extracting structured data. There's two words, I don't want to spoil too much, but we're also working on newer technology currently, which we call smart extract models. Those models will be able, because we have a couple of questions in the chat today, they will be able to handle documents in one go, basically. As we've explained, in some cases, you need to use a table model first and then a field model, as you might have mixed material, you might have tables in your data and some fields next to those tables that you also want to extract in a structured form. With our smart extract models, we are working on technology or models that you can train. Training is still something where we need to see how and who can train, because they're computationally a lot more intensive. but we will also try to provide out-of-the-box models with that technology. With this technology, you can basically train one model that is capable of doing everything. So getting tables out, getting fields out, getting baselines out, getting text out. So basically everything in one go, as you're mainly interested in the final end result, which is text in either structured form, enriched form, with potentially some words tag, which are text tags, which can also be done by smart extract models. So those will be introduced, let's say, this year still. We are still working on the final touches of these models, and hopefully can present these models to the public soon. So you might want to watch out for those, as we are very happy to have such new additions to our model gallery, or basically to our offering on the Transkribus platform. That being said, let's maybe jump to the very end, or basically to some questions you might have that might have come up in the meantime. So maybe let's dedicate the remaining time, it's 5 minutes, to some questions that we have in the chat. We have some right away, Sarah or Anya, that we could answer now in spoken form, or were you able to answer all those questions already in the chat?
I think we were able to answer most. There was one question that I think was perfectly timed with you mentioning the smart extract models. That was if there's a possible way to not do all these things in separate steps, one after the other. So that was great timing.
Okay,
But
good.
I
Yeah,
think
that's actually what we
otherwise,
aim for. Unless there's other questions, but yes, with those models, the great thing about those one-step models is that there is no error propagation, which means if you have a model making a mistake in step one, let's say an entire table column is left out, actually there's no way that the other models might fix this, because the table column is missing. So there will not be any baselines and not any text recognized for that column. So those models might help with a lot of those use cases. Yeah, there were quite. I can very quickly reiterate, but I said I don't want to spoil too much. So we're currently working on technology. There's different frameworks out there. We will call them smart extract models. And what you can do with those models is basically think of your models in a very different way as you do at the moment. You will start working on the end result. So you will work in the editor when you train a model. So you prepare your data by saying, that's the end result I want to have. You have a page with tables on it, with other structured data, marginalia, etc., and want everything extracted in one go. Then you sit down, basically start preparing your training data and say, okay, that's the format I want to have extracted. I want tables look like this. I want the other data look like this. And I potentially even want to tag all person names as a person. So knowing this is a person. That's something that you can do with those models. So prepare the output to the target output data, and then train a model that learns to do all things in one step. But yeah, I said once we are close to launching them and adding them to the Transkribus platform, we will certainly have webinars and other events where we explain how those models work and launch them. Yeah, is there anything left that we could?
There is one question regarding settings. And the question is, can I adjust the settings for when I have columns with just a few characters in the table fields, I'm guessing in a cell? For example, just a single number, and there were issues with Transkribus recognizing that as text.
Yeah, it's likely an issue with the baseline detection, I guess. So you need to tweak the baseline parameters in the advanced settings to have those very short lines recognized. That's what I would guess. But in general, we have worked with tables where you have, for instance, ditto signs, which is, to add again, another use case you could train your models on, the smart extract models, to resolve those ditto signs and always write the text that is above the ditto sign in that very specific cell and not just the ditto sign. So yeah, and when do you launch? So there is no launch date fixed yet, but I suspect it's towards the mid of this year. But not to spoil or promise too much because we're still in the last phase of integrating those models. We have used them very successfully in larger models, so where we manually use those models, so we know that they work well. But adding this to a software platform that many users can use it is a different story. So we're, as you've heard, a small team, are trying to do our best to further develop Transkribus as a platform to really provide the best tools, so that that's the idea of a cooperative, so that not every single individual must try to solve a problem individually and then have a solution for themselves. What we try to do is solve problems, provide them as tools on a platform that everyone can use, that the platform can then further develop itself basically on that usage and the share that everyone contributes to that platform, which is the idea of Transkribus. So that being said, I think I would leave it at that, as we are now slightly overrun. It was great to have so many of you here today, with this more specific topic about training table models. We always try to provide as much insight and help as possible. But in general, maybe we see you again next week when we talk about field models, which is a different application of a similar technology as table models. So looking forward to that webinar as well. And if there are some questions left, because I see some questions popping up still, feel free to write us an email. So we're happy to answer those questions via email as well. Our team is very diligent in replying to those questions that we get. So thank you very much. I hope we were able to explain those things that we tried to explain today when it comes to training table models, and hope you still have a great evening or morning wherever you join from, and keep unlocking with Transkribus. So see you soon, everyone, and bye-bye.